Section 1.2, Domain and Range. Learning Objectives. In this section, you will 1. Find the domain of a function defined by an equation. 2. Graph piecewise defined functions. If you're in the mood for a scary movie, you may want to check out one of the 5 most popular horror movies of all time: I Am Legend, Hannibal, The Ring, The Grudge, and The Conjuring. Figure 1 shows the amount, in dollars, each of those movies grossed when they were released, as well as the ticket sales for horror movies in general by year. Notice that we can use the data to create a function of the amount each movie earned, or the total ticket sales for all horror movies by year. In creating various functions using the data, we can identify different independent and dependent variables, and we can analyze the data and the functions to determine the domain and range. In this section, we will investigate methods for determining the domain and range of functions such as these. Figure 1. Top 5 grossing horror movies for years 2000 to 2013. Inflation-adjusted gross, in millions of dollars. I Am Legend, 2007. Hannibal, 2001. The Ring, 2002. The Grudge, 2004. The Conjuring, 2013. Market share of horror movies by year. Figure 1 based on data compiled by www.the-numbers.com. Note 3. The numbers. Where data and the movie business meet. Box office history for horror movies. http://www.the-numbers.com/market/genre/horror. Accessed March 24, 2014. 1.2.1. Finding the domain of a function defined by an equation. In functions and function notation, we were introduced to the concepts of domain and range. In this section, we will practice determining domains and ranges for specific functions. Keep in mind that, in determining domains and ranges, we need to consider what is physically possible or meaningful in real-world examples, such as ticket sales and year in the horror movie example above. We also need to consider what is mathematically permitted. For example, we cannot include any input value that leads us to take an even root of a negative number if the domain and range consist of real numbers. Or in a function expressed as a formula, we cannot include any input value in the domain that would lead us to divide by 0. We can visualize the domain as a holding area that contains raw materials for a function machine and the range as another holding area for the machine's products. See Figure 2. Figure 2. Function machine. Domain. Range. We can write the domain and range in interval notation, which uses values within brackets to describe a set of numbers. In interval notation, we use a square bracket when the set includes the endpoint, and a parenthesis to indicate that the endpoint is either not included, or the interval is unbounded. For example, if a person has $100 to spend, he or she would need to express the interval that is more than 0 and less than or equal to 100 and write, open parenthesis, 0, 100, closed square bracket. We will discuss interval notation in greater detail later. Let's turn our attention to finding the domain of a function whose equation is provided. Oftentimes, finding the domain of such functions involves remembering 3 different forms. First, if the function has no denominator or an even root, consider whether the domain could be all real numbers. Second, if there is a denominator in the function's equation, exclude values in the domain that force the denominator to be 0. Third, if there is an even root, consider excluding values that would make the radicand negative. Before we begin, let us review the conventions of interval notation. 1. The smallest term from the interval is written first. 2. The largest term in the interval is written second, following a comma. 3. Parentheses, open parenthesis, or closed parenthesis, are used to signify that an endpoint is not included, called exclusive. 4. Brackets, open square bracket, or closed square bracket, are used to indicate that an endpoint is included, called inclusive. See Figure 3 for a summary of interval notation. Figure 3. Inequality. Interval notation. Graph on number line. Description. 1. X is greater than A. Interval notation. Open parenthesis, A, infinity, closed parenthesis. Description. X is greater than A. 2. X is less than A. Interval notation. Open parenthesis, negative infinity, A, closed parenthesis. Description. X is less than A. 3. X is greater than or equal to A. Interval notation. Open square bracket, A, infinity, closed parenthesis. Description. X is greater than or equal to A. 4. X is less than or equal to A. Interval notation. Open parenthesis, negative infinity, A, closed square bracket. Description. X is less than or equal to A. 5. A is less than X is less than B. Interval notation. Open parenthesis, A, B, closed parenthesis. Description. X is strictly between A and B. 6. A is less than or equal to X is less than B. Interval notation. Open square bracket, A, B, closed parenthesis. Description. X is between A and B to include A. 7. A is less than X is less than or equal to B. Interval notation. Open parenthesis, A, B, closed square bracket. Description. X is between A and B to include B. 8. A is less than or equal to X is less than or equal to B. Interval notation. Open square bracket, A, B, closed square bracket. Description. X is between A and B to include A and B. Figure 3. Example 1. Finding the domain of a function as a set of ordered pairs. Find the domain of the following function: 2, 10, 3, 10, 4, 20, 5, 30, 6, 40. Solution. First, identify the input values. The input value is the first coordinate in an ordered pair. There are no restrictions, as the ordered pairs are simply listed. The domain is the set of the first coordinates of the ordered pairs: 2, 3, 4, 5, 6. Try it number 1. Find the domain of the function -5, 4, 0, 0, 5, -4, 10, -8, 15, -12. How to? Given a function written in equation form, find the domain. 1. Identify the input values. 2. Identify any restrictions on the input and exclude those values from the domain. 3. Write the domain in interval form, if possible. Example 2. Finding the domain of a function. Find the domain of the function f of x equals x squared minus 1. Solution. The input value, shown by the variable x in the equation, is squared, and then the result is lowered by 1. Any real number may be squared and then be lowered by 1, so there are no restrictions on the domain of this function. The domain is the set of real numbers. In interval form, the domain of f is, open parenthesis, -infinity, infinity, closed parenthesis. Try it number 2. Find the domain of the function f of x equals 5 minus x plus x cubed. How to? Given a function written in an equation form that includes a fraction, find the domain. 1. Identify the input values. 2. Identify any restrictions on the input. If there is a denominator in the function's formula, set the denominator equal to 0 and solve for x. If the function's formula contains an even root, set the radicand greater than or equal to 0, and then solve. 3. Write the domain in interval form, making sure to exclude any restricted values from the domain. Example 3. Finding the domain of a function involving a denominator. Find the domain of the function f of x equals x plus 1 divided by 2 minus x. Solution. When there is a denominator, we want to include only values of the input that do not force the denominator to be 0. So, we will set the denominator equal to 0 and solve for x. 2 minus x equals 0. Negative x equals negative 2. X equals 2. Now, we will exclude 2 from the domain. The answers are all real numbers where x is less than 2 or x is greater than 2. We can use a symbol known as the union, U, to combine the two sets. In interval notation, we write the solution. Open parenthesis, negative infinity, 2, closed parenthesis, union, open parenthesis, 2, infinity, closed parenthesis. Figure 4. X is less than 2 or x is greater than 2. Open parenthesis, negative infinity, 2, closed parenthesis, union, open parenthesis, 2, infinity, closed parenthesis. In interval form, the domain of f is open parenthesis, negative infinity, 2, closed parenthesis, union, open parenthesis, 2, infinity, closed parenthesis. Try it number 3. Find the domain of the function f of x equals 1 plus 4x divided by 2x minus 1. How to? Given a function written in equation form including an even root, find the domain. 1. Identify the input values. 2. Since there is an even root, exclude any real numbers that result in a negative number in the radicand. Set the radicand greater than or equal to 0 and solve for x. 3. The solutions are the domain of the function. If possible, write the answer in interval form. Example 4. Finding the domain of a function with an even root. Find the domain of the function f of x equals square root of 7 minus x. Solution. When there is an even root in the formula, we exclude any real numbers that result in a negative number in the radicand. Set the radicand greater than or equal to 0 and solve for x. 7 minus x is greater than or equal to 0. Negative x is greater than or equal to negative 7. X is less than or equal to 7. Now, we will exclude any number greater than 7 from the domain. The answers are all real numbers less than or equal to 7, or, open parenthesis, negative infinity, 7, closed square bracket. Try it number 4. Find the domain of the function f of x equals square root of 5 plus 2x. Q&A. Can there be functions in which the domain and range do not intersect at all? Yes. For example, the function f of x equals negative 1 over square root of x has the set of all positive real numbers as its domain but the set of all negative real numbers as its range. As a more extreme example, a function's inputs and outputs can be completely different categories, for example, names of weekdays as inputs, and numbers as outputs, as on an attendance chart. In such cases the domain and range have no elements in common.